All right. No, it is really, really exciting for me to have opportunity to be here at this meeting. When the organizers from OPAG and BECSAG both came to us at headquarters and said they were going to put this meeting together, I thought, what an awesome idea and a great way to bring together all these various communities that have an interest in exoplanets. We know that this is an area of research that's growing fast. We know it lies between a bunch of boundaries between our existing disciplines. And so this is a great opportunity to bring everybody together to share their ideas and help grow and move forward. And I'm also really excited that Doug Hudgens is here representing Astrophysics Division. I think Astrophysics and Planetary have been leading the way in trying to expand our knowledge of exoplanetary systems, but I think the other divisions are coming on as well, and we'll spend a little time talking about that this morning. What I thought I'd do is kind of start out for the folks in the room that are perhaps not planetary scientists by training or interest, and give a little bit of an overview of our current portfolio. I know there's a way to pull the lights down because Stephen turned them up earlier, so there's a way to turn them down. I think they're going, ooh, mood lighting. There we go. Excellent. Thank you. Right. So Stephen opened up this morning, I thought, with an outstanding talk that really kind of laid the groundwork for the importance of the inner solar system. And then we heard a lot about the outer solar system planets. So where are we today in our understanding, and what are we actually in planetary science trying to do about making sure we understand these important planetary analogs in our own backyard? So this is our current planetary science portfolio, our fleet chart that I show everywhere I go. And what you'll see here are, there's about 25 missions on this chart. Those that have yellow text or orange text for their names are in development. And those that are green or blue are those that are currently in operations or in extended operations. And so what you'll see, I'll just draw your attention to a few of these. I'm going to start with Bepi Colombo, which is right up in here. And this is a joint ESA-JAXA mission with two spacecraft to fly to Mercury. Within NASA, of course, we just a few years ago completed the Messenger mission at Mercury. Bepi Colombo launched in 2018 and will arrive at Mercury in 2025. NASA actually has an instrument on that mission, so we are a partner on that mission. And so we're trying to move forward with better understanding the magnetosphere, the magnetic environment at Mercury, and better understand the surface. But as Stephen said, the next step for really understanding Mercury is going to be a lander, and at the moment, that's not currently in anybody's plans. Stepping out beyond that, I'm going to skip Venus for the moment because you're going to notice there's nothing up here that says Venus on it. Yes, we'll get to that. We're going to get to that. And we're going to skip Earth because I don't actually get to study Earth in planetary science, even though Earth is a planet. But we rely on our Earth science partners to do the bulk of the heavy lifting there. And we think we know Earth pretty well. Although I'm sure there's still many, many things we need to learn. And I'm going to move on to Mars. So this is our current Mars fleet down here in the bottom right corner. We're really, I think, making a lot of headway in trying to understand Mars as a system. You'll see on the surface, we still have the Curiosity rover, which is doing fantastic work in Gale Crater to help characterize the environment that was present on the surface of Mars back in early history there, when there was probably a lake that was present in Gale Crater, really trying to understand the climate and the environment at that time. The InSight lander has now been on the surface of Mars for a little over a year. And this mission is really focused on trying to understand the interior structure of Mars, making a lot of headway there, measuring hundreds of Mars quakes, dozens of which are of magnitude large enough, about 3 or 4, that they can actually begin to really get at that interior structure. The Mars 2020 rover and the ExoMars 2020 rover, both of these rovers, this one from NASA and ExoMars from ESA, are going to be launching in July of this year. And again, we're really focused on trying to understand the biological environment and what could have, what types of biology may have been able to form at distant times in the past or may actually still be present on the surface of Mars, but again, trying to really understand that environment and what the environment of Mars was like billions of years ago. We also still have a pretty nice orbital fleet. Includes, again, NASA missions as well as partner missions from ESA and with JAXA that are either in orbit now or planned in the near future. Again, trying to really understand that the environment there, understand the atmosphere, understand the surface with detailed mapping, and understand the magnetic environment and atmospheric loss at Mars. So we're doing pretty well at Mars as well. Moving on to Jupiter, you can see we have a pretty good presence, or will have a pretty good presence at Jupiter in the near future. Juno, we heard about from Kathy earlier this morning, is already doing some really great mapping at Jupiter, trying to really understand the structure of the atmosphere, understand the composition of the atmosphere and how that composition changes with depth within the atmosphere, understanding the magnetic environment at Jupiter. So Juno doing great work, and then coming up in 2022 and perhaps 2023 or later, depending on launch vehicle considerations, we'll have the JUICE mission from ESA, which is going to study some of the moons in the Jupiter system, and Europa Clipper, which will be focused on understanding the environment at Europa. So not a bad suite of things going on in the Jupiter system. Of course, Galileo made measurements there several years ago. Moving to the Saturn system, Cassini recently completed its mission at Saturn, outstanding mission that really helped us to better understand Saturn itself and some of the Saturn moons. And of course, we now have one of the most recent missions we've added to our fleet chart, Dragonfly, which we was successful in the New Frontiers program of Planetary, is going to fly to the surface of Titan. We're going to send an octocopter to the surface of Titan, and it will take multiple hops and steps on the surface of Titan, trying to understand, again, the environment on the surface of Titan in this methane, ethane-rich environment, and understand if there are any biotic signatures that may be present on the surface of Titan. Moving out beyond that, you're going to see, again, there's another big gaping hole in this chart, which is Uranus and Neptune. And so that's really, I think, you're hearing a lot of that here today, that some of the most important planets in our backyard for understanding the exoplanets we're discovering are Venus, Uranus, and Neptune, and yet these are clearly the biggest holes in the current planetary fleet. So I'll talk a little bit about what we can do about that. There are a couple of ways we can think about it. This is just a standard chart that I show, but this shows our competed programs and the types of missions that we or the types of programs where we can have new missions in a competed environment. We do have a new program called Simplex, which we've recently made several selections in, but these are very small spacecraft. These are $55 million missions. We've made 3 selections this last summer for small sat missions that are in their phase A/B now, just trying to go through that early formulation stage. But these are focused on, we've got one going to the moon, we've got one going to a couple binary asteroid systems, and one set of 2 spacecraft that are designed to go to Mars. So again, not really addressing our problem at the moment, but maybe if we can improve our small sat capabilities, there may be some opportunities here to fill at least some of the gaps that we have. We also have New Frontiers program. I already mentioned that Dragonfly was selected this last summer, going to Titan, which is great. And we will be having another New Frontiers call in a couple of years. New Frontiers targets are defined by our Dekadal Survey. And already within the defined targets that we expect will be part of this next call are a Saturn probe, a Venus surface lander, the Venus In Situ Explorer. And we've been recommended by the Dekadal Survey to also add Io to that mix, which would diversify a little bit some of the targets. You heard a little bit earlier today, Io being another important target in the solar system. So there are opportunities there. There's also, we had last time around an Ocean Worlds category for New Frontiers. Dragonfly was selected there. There's still some ambiguity. We're asking the national academies to help us resolve whether or not Dragonfly satisfies that, or whether we leave that Ocean Worlds category there for potential Enceladus missions. So those are our competed categories for New Frontiers. Discovery is wide open. We actually, so those targets are not predefined. And so Discovery provides a great opportunity for people to come up with their own inventive and creative approaches to how to fill some of these gaps within the Discovery program. We are currently in the middle of a competition for Discovery. I cannot tell you what the next selected wins are going to be, but I can tell you that sometime in the very, very, very near future, we will be making step 1 selections from this most recent call of discovery. And we expect to have several missions that will be going through phase A, through a 1-year phase A, and stay tuned. I'm not going to give any hints. You'll just have to wait. I will tell you there were plenty of candidates, some of which filled some of the gaps that are here, but we'll have to wait and see. So that's kind of where we stand with the mission opportunities. I will talk a little bit about potential flagships and directed missions in a minute, but before I get to that part, I want to talk a little bit about some of the research opportunities, because until we have new missions, one of the things we can really do is focus on the types of modeling and using the data observations that we have in hand to really keep expanding our knowledge with the information that we have and develop new hypotheses that can be tested with new missions. We have a program already at NASA called the Exoplanet Research Program. It's been around for several years now. It has been traditionally a joint program with astrophysics, and I believe Doug will talk to this as well when he gets up here. But from my planetary perspective, we've been working really closely with Astro to try and make a few changes to this program to really make it more capable of answering the questions that we have about exoplanetary systems and really working more together in a cross-divisional and interdivisional and interdisciplinary way with not just planetary and astrophysics, but also with the heliophysics and earth science communities, because in my mind, to answer the questions that we have and to really push the science forward, we need expertise from all of these 4 disciplines. I think it's absolutely critical. And to that end, in 2019, the changes that we made was first and foremost to get some buy-in, get some skin in the game from both heliophysics and earth science. And so we now have those divisions participating with us on exoplanetary research. And they put a little skin in the game because it's important to them and to us that their communities recognize that the senior leadership at headquarters are encouraging them to participate in the exoplanetary research program proposals. We also made a change last year, which was in the past, proposals came in, and if they were exoplanet detection proposals, they went over to astrophysics to be assessed, and if they were planetary, comparative planetology proposals, they came to planetary for assessment, and never the twain shall meet, and they went their different directions and went through separate review processes. In 2019, we combined them together. And we said we will do one review process. We will rate all proposals based on merit. We will select the best proposals through that whole process, and then we will figure out who funds them at the very end. And so in that way, planetary put money into it, astrophysics put some funding in, helio, earth science, and we're all trying to fund the best work that's out there. In 2020, we also anticipate some changes. The new change is that we're trying to simplify your life by trying to find one program that covers exoplanetary research that you can apply to and not have overlap, or minimize the amount of overlap with other programs. And so what that means for you is that within the astrophysics, they're going to carve out some bits of some of their programs that Doug will speak about, carve those bits out that where there's overlap with exoplanetary research, put that science and a little bit of the funding into XRP. And for planetary science, the one program we have with the most overlap is habitable worlds. So we've been going through the definition of habitable worlds and trying to, again, be very clear about what belongs in habitable worlds and what part really can go into exoplanetary research, again, with the additional funding that comes along with carving out that section of habitable worlds. So I think that covers that mostly. And as I said, Doug will speak with that a little more, and we're happy to answer questions a little later. You may have also seen just recently there was a call that came out looking for research that falls in a gap between the current Science Mission Directorate solicitations for research. And I think this is a really important area. I hope that some of the folks in here put in some ideas. If you have science research that you feel has fallen on deaf ears in whatever programs you've tried to submit them, and everyone says it's not in my house, it belongs over there, and that person says not in mine, it belongs over there. This was exactly the place to put it. Hopefully it went in. These were due last Friday, and we're now in the process of going through those, looking at them, trying to look at each one of these and say, do they really fall in a gap? Is this something that we really think we have a program? We're just our science community just isn't finding the right program, or is there really a gap there? And so we're going through that now, and hopefully we'll identify if there are specific areas where we maybe need a new program that can address some of these gaps. So if there are things here, I hope they went into that call. I also wanted to mention our astrobiology program. Of course, within astrobiology, over the last few months, we are instigating the process of sunsetting the NASA Astrobiology Institute, but in the same time, we're also putting a lot more emphasis on our research coordination networks. And of course, Nexus was the first of these RCNs that was started, what was it, 4 years ago? Looking for Sean or somebody to confirm, 4 years ago. So it's been around for a few years now, up to almost 5, okay. So Nexus has been a really important opportunity to bring together people that are funded through a bunch of different programs already. So they get their funding through their regular solicitations, but we bring them together to work as a research coordination network and amplify and coordinate that science to hopefully get more than the sum of the parts. And Nexus has been an excellent example of that. When we sunsetted the NAI, one of the big things that came up from the science community was that the NAI offered a really important and unique venue for people to write proposals for large grants that were longer duration. They were 5-year grants, they were multi-million-dollar grants that really allowed major advances to take place in astrobiology. And so we didn't want to lose that part of the NAI. So as NAI sunsetted, we developed a new call called the Interdisciplinary Consortia for Astrobiology Research, or ICAR. And this is a new program. It will be large proposals, multi-year proposals, up to 5 years. And in the current call, which the step 1s were due last week, step 2s in April, we are focusing on 3 of those research coordination networks, with Nexus being one of those. So if you write a successful proposal to ICAR, there is an opportunity to join the Nexus RCN. So I mentioned the current portfolio of missions that we have. I talked about the competed opportunities that we have for new missions that might address some of those gaping holes in our portfolio. The other potential way to fill some of those holes is through our Dekadal Survey process, which is going to kick off this summer in June. We are really looking forward to this because the Dekadal Survey will not only provide recommendations for big flagship missions, but it will also potentially take a look at those new frontiers, destinations, and science objectives and provide an opportunity to update those. So this is the time right now to be thinking about, what do you need to tell as a community? What do you need to tell the Dekadal Survey to focus on? What are the most important science priorities? And I've already heard of a bunch of white papers that are going to go in with a focus on the importance of planetary science as analogs for exoplanetary science. And so I think that's great. I think those are great messages to send the Dekadal Survey. And certainly any mission ideas that can help feed forward to understanding exoplanets, the Dekadal process is the way to do that. So we have right now, in preparation for Dekadal Survey, Planetary Science Division is funding 11 concept studies to go off and look at various mission concepts from New Frontiers class and larger. Those reports from those studies will feed into the Dekadal Survey process, and the Dekadal Survey panel will be able to look at those and weigh them against the science priorities that they think are important. I will note that there were many, many more great ideas than we could possibly fund through this call, but there will be opportunities for the Dekadal Survey to conduct additional studies as part of the Dekadal Survey. So if your concept study or your idea did not get through, or you look at the list and you think there's a gaping hole, please make sure that you send in your mission concept ideas to the Dekadal Survey and through white papers, which will open hopefully in the next month or so. In the next few weeks, I believe. So we definitely encourage you to submit those white papers. And this is our process. It's going to be very similar to the last planetary decadal process. For those that are involved with Astro 2020, it's a little different. We are only going to have one submission deadline and one white paper style. It will just be the 7-page version. So it's a little simpler than the Astro 2020 approach. As I said, that website should open soon. We already have, in addition to the assessment group, individual websites where people are coordinating white papers. LPI has also a website where people can coordinate different white paper ideas, and you can start to bring together your folks to co-sign on your paper or join up with other people's papers. As far as preparing for our Dekadal Survey, we expect to have an early career workshop on the Sunday before LPSC. It's a 2-hour workshop. I don't know the time of that workshop. It will be on Sunday, the 15th of March at 10 to 12. Thank you, Doris. So that is an opportunity. It's aimed at trying to target our early career scientist community to help them better understand and learn about the Dekadal Survey process and how they can best be engaged and be a part of the whole Dekadal Survey going forward. There'll also be an LPSC town hall led by the National Academies, and I believe that is on Tuesday at lunchtime. And then there will be all day Sunday prior to LPSC, the Planetary Mission Concept Studies that I mentioned, those 11 studies will have an all day workshop where each of those concept studies will present where they are and have an opportunity for feedback from the community on where they're going with those different concept studies. I also just wanted to mention, I like to put this in, this is a new activity for Science Mission Directorate. I'm really excited that yesterday at OPAG there was a fantastic presentation on this new PI Launchpad. But as I said, we have all of these competed opportunities and we want to make sure that we are reaching the broadest audience with the best and brightest ideas that can propose those competed mission concepts. And so just in November, we kicked off the first PI Launchpad. This was a great activity, and the reports we had yesterday from the participants were absolutely just mind-blowing. It sounds like a really wonderful workshop. We're hoping for more in the future. This is run by Science Mission Directorate. There was a very competitive application process. There were 40 participants in this first PI Launchpad. We were lucky that there was some external private funding, which really allowed us to do more with this workshop than we could do if it were just NASA money. So hoping to be able to continue that approach in the future. We are actually targeting another workshop like this, perhaps this spring. I don't know if Michael New can speak to that. I don't see if he's in the room, but you maybe, when we have question and answer, maybe you can speak to that on where the status is on that. But I just wanted to mention that for folks in the room that maybe weren't aware that this is coming along, as far as how do I get my great idea as a proposal to NASA. You might want to look out for participation in this Launchpad activity. And with that, I will stop and I'll let Doug speak about the astrophysics position. Thank you.